Okay, let's get started with this last session on Tuesday here. And we're going to do where Darwin went wrong. And I'd like to begin by saying that, you can evaluate somebody 150 years later by the standards that we have today. And we can talk about Darwin's errors, how Darwin went wrong, where Darwin went wrong, and why Darwin went wrong. But, and we need to be careful with that because we don't want to evaluate it by today's standards. We could say, well, if Darwin knew what I know today, or if he saw what I saw when I went to his campsite, then he should have thought it this way. That's not the way to critically evaluate a historical figure like Darwin. You want to evaluate Darwin by what he knew, and by what he saw, and how he interpreted what he saw. And that's the point I want to make today. I'd like to point out that Darwin made some very good scientific observations in an area that was a classic area to understand this issue of Earth history. But he did it with sunglasses on that skewed his view of the world around him. And so he was wrong. And he had some interpretive problems. Now we have the picture of Darwin as the old man, right? Darwin is the old man, but really what I want you to think about is Darwin the young man. Okay, Darwin was a young man and he took a trip on the Beagle. 1834, he was down in Argentina and he made his observations, and really that's the time when the critical thinking of Darwin came about. We find out a lot about Darwin's journey on the Beagle, the 3-year voyage around the world, by Darwin's notebooks from the Voyage of the Beagle. So Voyage of the Beagle is the source, a lot of this. And there's notebooks and published things, and I had the privilege of going to Darwin's locations where he and the crew of the Beagle made some of these critical observations. And so I'd like to tell you what I saw, what Darwin saw, and talk about the issues that he confronted and confront them. For example, Darwin's journal has these very interesting statements. He's seeing the Santa Cruz River in southern Argentina. The river, though it has so little power in transporting even inconsiderable fragments, yet in the lapse of ages might produce by its gradual erosion an effect of which difficult to judge the amount. I read that and I said, I need to go to see Darwin's campsite. So the Voyage of the Beagle went there April 26, 1834. He's writing this in his journal, and I need to go there to see this. So I'd like to talk about where Darwin went wrong, the campsite where he was, how Darwin went wrong, and maybe why Darwin went wrong. So that's but let's just call it where Darwin went wrong. Where Darwin went wrong, how Darwin went wrong, why Darwin went wrong. I would like to co-author with a philosopher a little bit about the why Darwin went wrong. Let's expel some myths about Darwin. Darwin had a rock hammer, okay? Darwin's rock hammer. Darwin did geologic maps. Here's his geologic map of the southern part of South America. Isn't that interesting? Darwin drew stratigraphic cross-sections and the sequence of rock layers. Darwin's drawing of the basalt cliffs along the Santa Cruz River, for example. There's the basaltic lavas, There's sedimentary layers above and below the lava flow layers. And he measured thicknesses. He did things like geologists should. In fact, Darwin took a traverse across the Andes Mountains. In the upper diagram you see there's his cross-section of the rock layers that he saw on his traverse of the Andes Mountains. Down below is Ramos's 2009 cross-section that he drew of the same crossing area. So what am I trying to say here? Darwin said he was a geologist, and he was a geologist. I, as a geologist, have a defined notion of land covered with oceans, former animals, slow forces cracking the surface. And Darwin said he was a geologist. I'm interested does anybody know if Darwin said he was a biologist? We have this impression that Darwin was a biologist, and no. In his papers that he wrote, most of them before mid-1840s, those papers prove that he was a geologist in his way of thinking. I, as a geologist, have a defined notion of land covered by oceans, former animals, slow cracking forces of the surface. And he said he was a geologist. As I thought about Darwin was interested in the same things that I'm interested in. He was interested in tectonics, sedimentation, fossils. Those are the same, and erosion. Those are the four things that Darwin wrote about in his journal. And so that's interesting. And so the idea that Darwin was on the Beagle, studying in detail the finches on the Galapagos Islands, or looking at the condors in southern Argentina, or working with the llamas of the Patagonian desert, that type of thing. No, Darwin was interested in all the animals, but his focus and his passion was for geology. In fact, there's a book out called Charles Darwin, Geologist. Okay, Sandra Herbert, 2005, Cornell University Press. By the way, he has this on the cover of the book, his cross-section of the Andes Mountains. You see that on the book? Okay, Darwin, that's the way Darwin was thinking. Darwin saw world-class geologic features on his voyage of the Beagle, the 3-year voyage. He saw the boulders of San Sebastian. He saw the valley of the Santa Cruz River. And he saw the earthquakes and the tsunami of Conception. The boulders of San Sebastian, that's along southern Argentina and its border with present-day Chile. And the valley of the Santa Cruz River is up in the Patagonian desert, a little bit north of the boulders of San Sebastian. And the earthquake and tsunami of Concepcion, that is farther north along the Pacific side of Chile. I've drawn it on a map there. You see the Santa Cruz River. Let's see if I point at it, will you see it? Okay, I got to go over here to do this. There we go. See that? There's the Santa Cruz River in the Patagonian region of southern Argentina. Latitude about 45 degrees south, so that's pretty close to getting pretty close to the equator, or to the polar area. There's San Sebastian along also the Atlantic side of Chile on the border. He went through Tierra del Fuego, and then he went up to Concepcion there in northern Chile. He was on the way north as the earthquake and tsunami hit Concepcion, a big earthquake and tsunami. Here's what he saw, Bahia San Sebastian. He saw these boulders along the shore, and he was fascinated by boulders because his educators, as teachers, had talked to him about it, and because Charles Lyell had said, hey, pay attention to erratic boulders when you get down there, because you'll probably see them. And here are granite boulders of the type that he put on his map that were in the center of the Andes Mountains, and here they're out 100 miles away from the Andes Mountains on the coastal plain. Here you see the boulders along the shore. Where do the boulders come from? The boulders come from the elevated coastal plain up there. You see how that plain is up there? You go up on that plain and you see the boulders up there on the plain. That's the source of the boulders. The question is, how did the boulders get there onto the coastal plain? Darwin saw the San Sebastian boulders and he realized they come from the plain up there, and he pointed that out. After the remarkable discoveries of Venetz, Carpentier, Agassiz, and others of the great extent in Europe of moraines formed by ancient glaciers, it is necessary to observe that neither the till beds of eastern Tierra del Fuego nor the stratified gravel and till can have been produced like ordinary moraines, and therefore the embedded boulders cannot have been propelled by the glaciers themselves. And so Darwin saw the boulders of San Sebastian, and he said the boulders were transported by floating ice. He wrote about that in his paper on the distribution of erratic boulders. It's interesting that field research conducted by Everson and his colleagues in 2008, they pronounced that deposit right there, a lateral moraine. A lateral moraine is where on the margin of a glacier. And so Darwin had a strong opinion about boulders not being driven by ice. His idea was that they were floated in on icebergs and they're dropped. They're not direct deposits of glaciers. Now that would have been a modest error. I think Darwin should have gotten that right, because he had been instructed by Buckland and Cuvier and his teacher, or Buckland and Sedgwick as teachers, to recognize glacial deposits. Then what he did was he went north, and near Santa Cruz in Patagonia, he entered the estuary of Santa Cruz, Argentina, and they moored the Beagle, and then they took boats, large whale boats, and pulled them up the river, over 70 miles up the river to this area before you get to Lake Argentino, the big lakes, marginal to the Andes. He didn't get all the way to the lakes. He didn't get to the Andes on the eastern side because of the considerable distance, but he got to the Andes on the western side. Anyway, there's Camp Darwin, I call it, is April 26, 1834. That's where Darwin camped when he wrote about the river having so little power, but in the lapse of ages might produce by its gradual erosion. Then he went up to the boulders, and he wrote about the boulders he saw higher up along the river. and he wrote about those. And of course, they're deeply floating icebergs, not glacial deposits either. Here's Valley of the Santa Cruz River. Look at this. The valley is 10 miles wide, and the river is only 1/10 of a mile wide. So the floodplain is what? Really wide, 10 miles wide. The river's minor. You see how the river migrates around in that, meanders around in that big wide floodplain. Obviously an underfit river, but that's the river that Darwin came up. He came up and stayed right here at what I call Camp Darwin. Here's Camp Darwin area. You're looking at the basalt cliff along the edge of the Santa Cruz River Valley. You see the Santa Cruz River itself. Here's what I call Camp Darwin. This is where he camped April 26, 1834. April 26, 1834, they had the boats pulled in. We know that it's right along this beach area right here because one of the crew drew a sketch of the cliff above and the canyon going up there. And so obviously they walked up that a little bit, and so they experienced that. So this would be one of the big campfires of most important campfire discussion of history, I would say. At Camp Darwin, Darwin gets into a conversation with Fitzroy, Robert Fitzroy, the captain of the Beagle, and obviously they're talking about how do we interpret this valley, and obviously the discussion of scripture comes up, and the creation and the flood view, and Darwin takes the position of Charles Lyell. At first glance of basaltic cliffs on the opposite side of the valley, it was evident that the strata were once united. What power then has removed along a whole line of country a solid mass of very hard rock, which has an average thickness of nearly 300 feet? He asks the question, and the breadth varying from rather less than 2 miles to 4 miles. The river, though it has so little power in transporting even inconsiderable fragments, yet in the lapse of ages might produce by its gradual erosion an effect of which is difficult to judge the amount. Darwin thought in terms of slow and gradual process. He actually disputed the idea that the river actually eroded it slowly. He thought it was some type of estuary of the ocean that was up in the valley, and that and the glacier icebergs, the glaciers, floating glaciers, icebergs were dropping the erratic boulders. Darwin on the Santa Cruz boulders. The boulders on the lower levels, the head of the Santa Cruz River, were strewn on land, which certainly had been modeled by the action of the sea. This little inclination of the surface and the absence of mounds or ridges on it and the angularity of the fragments are opposite to the notion that the blocks have been pushed to this great distance by glaciers. Hence, I conclude that the boulders were transported by floating ice. If you look at the campsite, right downstream from the campsite, you can see the diluvial dunes. Look at the side of the valley, giant diluvial dunes, and what does it look like? A gigantic flood came through here of water, probably 300 feet deep. And the giant boulder bar all along the river, especially here on the south side of the Santa Cruz River, over there, Darwin's area, the north side. Anyway, that is the, that's obviously the boulders that Darwin saw. There's evidence upstream that there was a gigantic lake, Lake Argentino area, and that those diluvial dunes on the side of gravel dunes or boulder dunes on the side of the the river valley were created by catastrophic drainage of lakes. In other words, a megaflood, 1 million cubic feet per second of, 1 million cubic meters per second of water came down the valley, and unlikely that the valley was cut by the normal action of the Santa Cruz River over the lapse of ages. So Darwin had this position that he got from the reading Charles Lyell. In fact, he had the book, Charles Lyell's Principles of Geology, with him on the Beagle. And that's probably at the campsite when he got into the discussion with Fitzroy about the erosion of valleys and the big boulders that they were seeing, that he took the position that the boulders are floated in by icebergs, and the river or the ocean in an estuary has slowly eroded the valley. Then they went back up into the high country, or they went north over into the Pacific Ocean and along, and they went and saw the earthquake evidence and the tsunami. February 20, 1835 was the earthquake and tsunami, and weeks later they pulled in and they saw this. There's the beach, boulder beaches, and then they pulled in, here's a Google Earth image, and they went into this bay and Concepcion here, and then they did the traverse of the Andes Mountains. This is the conventional view of mountains. Hopkins' sketches. Hopkins had this idea that shrinkage and cooling creates mountains, and shrinkage creates these shrinkage cracks, and here's Hopkins' ideas of mountains, and that's the theory that Darwin defended. Okay, he thought that the forces in the mountains or directly under the mountains deformed the mountains. That was the tectonic force. And then he drew this diagram to suggest it. There's this cross-section of the Andes Mountains. Ramos's diagram is quite different. It doesn't have vertical tectonics, it has horizontal tectonics. And you see these are a series of slices that have been overthrust from each other. So the force that made the mountains in the newer explanation, or the better explanation, is that horizontal force pushing from the west to the east shoved the mountains over themselves in a series of thrust faults. So tension versus compression. Okay, interesting views of mountains. Darwin was wrong about geology. Darwin rejected catastrophism. Boulders of San Sebastian were deposited directly by a gigantic glacier. Ocean icebergs is the way Darwin thought about it. The valley of the Santa Cruz River was eroded by a colossal glacial outburst megaflood. The dune-like structures along the valley that he saw at the campsite should have convinced him. Instead, he proposed slow marine, then slow river erosion. That's the Santa Cruz River. And then the earthquake and tsunami of February 20, 1835 at Concepcion illustrated an episode of compressional uplift of the islands offshore by forces from offshore. And of course, Darwin thought of slow and continuous tensional arching of the mountains by forces directly under the mountains associated with cooling. Darwin's wrong about geology because, why? I can tell you why. He accepted the theories of Charles Lyell. He wore these sunglasses that skewed his way of looking at the world and into a uniformitarian way of thinking.
Can I ask a question?
Sure.
Who paid for Charles Darwin doing all this work?
Well, he was well off, and he was available for 3 years, and he is a good hand. So anybody, the Beagle was a research trip, and they were paid to survey southern Patagonia and South America. So they were funded by the government of England. Okay, there was a question asked on Darwin's Day, October 19, 2009. What is Darwin 2009? 2009 was the 200th anniversary of the birth of Darwin. And so at the Geological Society of America meeting, there was a Darwin Day meeting. Why Darwin Day at the Geological Society of America? Because Geological Society of America wants to claim, take possession of Darwin as a geologist. Okay, and geologists need to assert themselves and say that Darwin was a geologist. And let's explode the myth that he was a biologist. And but anyway, I remember sitting in the back of the session on Darwin's Day, and one geologist raised their hand and then asked this question: if Darwin had not published Origin of Species, would we even want to remember his geologic work today? And you know what? We heard a hush over the whole audience. People have read Darwin's geology papers, like some of the quotes I've given you, and there's not much in the way that's good or worthy to be remembered about Darwin's publications. He has 10 peer-reviewed publications, largely Geological Society of London. He had a rock hammer, he had he drew cross sections, and he drew strat sections. He did all the kind of things that geologists did, but it's kind of a dud when you come to think about it. So where Darwin went wrong.